Hi, everybody. My name is Mengyi Hu, and I am the staff scientist for food and bakery applications here at Innophos. Today, I would like to talk to you about reducing waste and boosting sustainable production by improving batter stability. Let's go over the agenda of today's presentation. We will first talk about food waste that happens at production level, the bakeries, and the production challenges that could lead to waste. We will then discuss how to address these challenges with leavening acids, thus reducing waste. We will demonstrate the solution with two case studies, sweet baked goods, including cupcakes and muffins, and then pancakes. Lastly, we will have a brief summary to recap the presentation. The bakery industry is focusing on environmental sustainability as consumers are caring more about the impact production has on the environment. Many of the bakeries are taking their sustainability initiatives to the next level on multiple aspects, such as better energy efficiency, reducing greenhouse gas emissions, and eliminating food waste. In particular, bakery wastes are produced at every stages of production. In general, bakeries generate about 5 to 10% of production waste. During production, bakers face two main challenges in keeping the batter consistent: floor time and batter temperature. In a perfect scenario, after the batter is mixed, it would have a reasonable floor time as it's being deposited, then baked. However, extended floor time can occur for many reasons: equipment failure, changeover of equipment, or changes of parameters. Packaging can't keep up and now you have to hold off baking, and or foreign material get in the line and sanitation needs to be done, etc. The longer the batter sits, the more of its characteristics change and become inconsistent. Batter temperature is another critical factor that affects the consistency and performance of the batter. In most bakeries, it is common for production areas to get well over 100 degrees Fahrenheit in summer months. Ingredients stored in bulk, such as flour, are also main sources of temperature fluctuation throughout the year. Inconsistent batter will affect crumb structure, texture, and volume of the finished product, leading to quality inconsistencies and waste. Exactly how do floor time and batter temperature affect the performance of batters? The answer is by affecting the leavening system. During extended floor time, the leavening system in the batter continues to react and generate expansion. Overexpansion during holding can lead to viscosity development and coalescence of air cells to form larger cells that are buoyant and easily lost during baking, resulting in smaller volume of the finished product. As for batter temperature, an increase in batter temperature can activate leavening too early in the production process. This can result in cakes with low volume and coarse grain. These cakes may be fragile and crumble easily when handled. Low batter temperatures can delay leavening action and result in a tough crumb with cracked tops. By leveraging the functionality of leavening acids, we can effectively control the reaction rate of the leavening system, stabilizing the batter and preventing waste. All leavening acids have a characteristic dough rate of reaction, DRR, which is the percentage of carbon dioxide produced over time at a given temperature. Acids with slower DRR would generate a lower percentage of carbon dioxide during mixing and floor time, retaining a higher percentage of the gas for release later in the process. Acids with faster DRR will produce more carbon dioxide during mixing and floor time. And on top of this, the same leavening acid will have a faster DRR when the temperature is higher, leaving less carbon dioxide to be released later. The graphs below compare the DRR of LEVAIR Stabilize, a solution from our LEVAIR baking innovation portfolio, to the DRR of a commercial double-acting baking powder at 27 degrees Celsius as well as 40 degrees Celsius. As the reaction time increases, the commercial baking powder releases up to 40% of its CO2 at 27 degrees Celsius and up to 59% at 40 degrees Celsius. This is a 19% difference. LEVAIR Stabilize only releases up to 27% of its CO2 at 27 degrees Celsius and up to 40% at 40 degrees Celsius, a 13% difference. This tells us that LEVAIR Stabilize is not only more time tolerant than the commercial baking powder, but also more temperature tolerant. Now, let's look at some applications as case studies. These case studies demonstrate how adjusting the leavening system in the formulation improves batter stability and finished product quality in different time and temperature conditions. First, let's look at sweet baked goods. We conducted a study on a commercial cupcake formulation as well as a muffin formulation. We selected a commercial double-acting baking powder that's commonly used in the industry as control, and LEVAIR Stabilize as test. Both batters containing control and test were exposed to different temperatures, 70 degrees Fahrenheit and 100 degrees Fahrenheit, for different amounts of time, 15 minutes, 30 minutes, 45 minutes, and 60 minutes before being baked. This is to simulate the extended floor time and elevated batter temperature in a production setting. The batters were measured for their consistency, specific gravity, and pH. Baked cupcakes and muffins were evaluated for their specific volume, pH, and water activity. Our results show that cupcakes and muffins baked with LEVAIR Stabilize have higher volumes than control after the batters were held at elevated temperatures after an extended period of time. Let's look at the data. In the chart on the left, the gray bars represent specific volumes of cupcakes baked with control, which is a commercial double-acting baking powder. You can see that after being held at 100 degrees Fahrenheit for 60 minutes, the baked cupcakes lost 17.9% in volume compared to batter that was held at 70 degrees Fahrenheit for 15 minutes. This shows that the leavening system in the batter had been significantly affected by extended floor time and elevated batter temperature. Now, let's look at the difference it makes just by modifying the leavening system. The blue bars represent specific volumes of cupcakes baked with LEVAIR Stabilize. After the same treatment of 100 degrees Fahrenheit batter temperature and 60-minute hold time, LEVAIR Stabilize was able to retain most of its leavening power, and the finished product only lost 7.1% in volume. Seeing is believing. Let's take a look at the image here. These are the muffins baked with the commercial baking powder or LEVAIR Stabilize, with the batters undergoing the same time and temperature treatment as the cupcakes. We can see that there is minimal volume reduction after the batter treatment of 100 degrees Fahrenheit for 60 minutes. Comparing this to control, which has a significant loss of general volume, not only in height, but also in circumference. To recap, the data we have obtained from these case studies verify what we have seen earlier in the DRR chart, that LEVAIR Stabilize is much more temperature and time tolerant than control, providing higher volume for finished products after extended floor time and elevated batter temperature. Now, let's turn our attention to the batter. Before we dive into this, the main message that I would like to talk about is that by optimizing your leavening system, you can increase your batter stability, resulting in a more consistent batter flow after extended floor time and elevated batter temperature. To measure the flow consistency of batter, we use a Bostwick consistometer, as shown on the left here, which measures how far a viscous material freely flows for a set amount of time. In our case, we let the batter run for 30 seconds, then take our reading. As the floor time of batter increases, the batter thickens, and you will get a shorter Bostwick flow. As the batter temperature increases, the batter thins, and the Bostwick flow will be longer. Why does this matter? Take depositing, for example. Accuracy and speeds are important in this process. Changes in flow rate of batter will pose challenges in getting the batter to flow into the machine consistently, to flow freely from the hopper, and dropping the batter freely into trays. Let's take a look at this chart. This chart compares the different Bostwick flow distances of cake batters made with a commercial baking powder and LEVAIR Stabilize, having undergone time and temperature treatments of 70 degrees Fahrenheit versus 100 degrees Fahrenheit for 15 minutes versus 60 minutes. Now remember, the longer the floor time, the shorter the Bostwick flow. The higher the batter temperature, the longer the Bostwick flow. So the shortest Bostwick flow would occur at 70 degrees Fahrenheit at 60 minutes, as shown for the bottom lines here. And the longest Bostwick flow would be at 100 degrees Fahrenheit for 15 minutes, as shown at the top lines here. You can see the commercial baking powder on the left here fluctuated quite a bit under the different time and temperature treatment, while the cake batters containing LEVAIR Stabilize is rather stable regarding its flow consistency. Now let's look at another case study. Pancakes is another product of which quality is determined by the quality and consistency of its batter. In food service settings, it is common to make a large batch of batter, then hold it at refrigerated temperature until it's ready to be used. The hold time varies, sometimes as long as overnight. This case study is designed to evaluate the impact of LEVAIR Stabilize on the volume of pancakes when the batter is exposed to such conditions versus a commercial double-acting baking powder as a control. Both pancake batters were held for 0 as well as 2 hours after mixing, then refrigerated for different amounts of time, 0, 6, 8, 10, and 12 hours, before being cooked on a griddle. The batters were evaluated for their consistency, specific gravity, and pH. The cooked pancakes were evaluated for stacked height, 4 pancakes per stack, hardness, diameter, and pH. Our results show that time-tolerant batter containing LEVAIR Stabilize resulted in pancakes with greater volume and softer texture. The chart on the left here demonstrates the stacked height of 4 pancakes for control versus LEVAIR Stabilize, with the batters being refrigerated for 0 hours versus 10 hours. Similar to what we have observed in the sweet baked goods case study earlier, extended holding time of the batter reduced the height of the product, as shown by the gray bars here, which are pancakes made with control. By modifying the leavening system with LEVAIR Stabilize, we were able to create a more time-tolerant pancake batter, reducing the loss of height of finished product, as shown by the blue bars. In addition to the advantage in volume, pancakes made with LEVAIR Stabilize also had a 33% softer texture than those made with control. To recap this presentation, first, floor time and batter temperature can have significant impacts on batter, which leads to product quality inconsistencies and waste. Second, reaction of the leavening system is important in maintaining batter stability during extended floor time and at varying batter temperatures. Lastly, batters of sweet baked goods and pancakes can be stabilized to be more time and temperature tolerant with leavening technology, delivering higher volume and softer texture in finished product, thus reducing waste. Thank you for attending this presentation. If you have any questions, feel free to reach out to me at the email displayed here.